This video is on how to find the domain of a function. First, the domain, just as a review, domain is the x values that you can allow in the function. And we're going to be focusing on finding the exclusions. Those are the values that we cannot use because either we're going to get an imaginary number, that's not a real number, or we will end up with an undefined number. And we want to avoid both of those situations. So here are the two most common situations. First, if we have a radical, if our function has the variable under the radical sign, that is in the radical expression. Now the radicand is the expression underneath the radical sign. So if there's an x there, what you need to do is identify all the values where x would be 0 or positive. Or you can say that you're going to look for the values of x that would make that a negative radicand, and that would give you an imaginary number. So the easiest thing to do is solve for x being greater than or equal to 0. Okay, in this case, the expression that I'm trying to solve for is just simply x, because that's all there is. So I'm going to set that whole thing up here as x is greater than or equal to 0, and then solve. Well, that's pretty simple. X has got to be greater than or equal to 0. On the number line, it would look something like this. I would set the values as x is greater than or equal to 0, and it would basically be everything that's positive. Okay, that's a real simple one. In interval notation, it would look something like this. The 0 is included, and we go all the way to positive infinity. So it would be bracket 0, comma, infinity, and a closed parentheses. So let's take a look at another one. Here we have g of x is equal to the radical 6x plus 5. So what I'm going to do is set up this 6x plus 5 as being greater than or equal to 0. And solve. And just do a little algebra here. 6x is now greater than or equal to negative 5. And this x is greater than or equal to negative 5, 6. And so the only values we can use for this function are values of x that are equal to, greater than or equal to negative 5, 6. So an interval notation would look like this. We're going to start with and include negative 5, 6, and of course go all the way up to positive infinity. Okay, let's do this last one here. Negative 3x plus 1 is the radical expression, so we want to set all of that as greater than or equal to 0, and then solve. So we'll end up with negative 3x is greater than or equal to negative 1. And then I'm going to divide both sides by negative 3. And remember, when you do that with an inequality, you have to flip the sign. So I'm going to turn this into a less than or equal to 1/3. Okay? And in interval notation, that would be written as this. So x has got to be smaller than or equal to 1/3. So that means I can go all the way to, so there's little parentheses here, negative infinity, starting with negative infinity, go all the way up to 1/3. And it does include 1/3, so I would use a bracket. Okay? So again, you just want to solve for the radical expression being equal to or more than 0. Let's try some other ones. Here we have the expression that includes x is in the denominator of a function. So in the first one, f of x is equal to 1 over x. I'm looking for any values where x is not 0. For these, what you want to do is find the exclusions. So basically where x is equal to 0. In this particular case, x can be any number but 0. So on the number line, it would look something like this. I would have a hole or a circle over the 0, and then basically be everything greater than 0 and everything less than 0. Okay, in interval notation, it would look like this. negative infinity up to 0, but excluding 0, and the union of that set with 0 all the way up to positive infinity. Okay, let's try some that a little harder. In the second one, g of x equals 1 over x minus 7. What I want to do is figure out the values of x that would make this denominator equal to 7. Now, some of you can do it in your head, but if you want to do the algebra, you'd put x minus 7 is equal to 0 and solve. And that would be positive 7. So this would be very much like the first one, except we're excluding 7. So from negative infinity up to 7, and then from 7 to positive infinity. Okay. And then the last one here that I've got the example of is 1 over 2x. I just can't have a 0 here, so this one should be negative 2x equals 0. X would have, if x is 0, that's going to create that situation. It's the only number that would cause this denominator to be a 0. So for that one, whoops. Okay, we just want to write an interval notation from negative infinity all the way up to 0, and then from 0 to positive infinity. Okay. Just to recap, if you have radicals, what you want to do is solve for, and this is going to be your radicand. That's the expression under the radical symbol, greater than or equal to 0, to find the domain. For rational functions, you want to solve for, and here we're going to put the denominator, everything in the denominator, equal to 0. And in this case, you're finding the exclusions. You're finding all the values that x cannot be, where in the first one, you're finding all the values that x can be. So let's try a couple more. So for this one here, we have y is equal to, and I'm using y instead of f of x. Y is equal to 16 over 10x minus 5. Well, I'm concerned about this denominator not being a 0. I don't really care about the 16. That's not our task. The task is to find the domain. So all I'm going to do is find the exclusions. So 10x minus 5 equals 0. And then we've got 10x equals positive 5. And x equals 1/2. So really, x can be any number except 1/2. And again, in interval notation, we'd say negative infinity up to 1/2. And the union of that set with 1/2 to positive infinity. Okay, now for this last one, that's a radical. It's this, x plus 8, that cannot end up being negative. So I'm going to solve this for all values where x is greater than or equal to 0. So it's either positive or it's a 0. And of course, we end up with x greater than or equal to negative 8. And on the number line, that's going to look like from negative 8 all the way up to positive infinity. In interval notation, we're going to start with negative 8 and include negative 8. So I'm going to use a bracket and go all the way up to infinity. There you go. And thank you for watching this video.